We are back again and we are still doing momentum. So let's do this question paper here. Let's read along and try to grab some important information. So it says the diagram below shows a toy wagon of mass 6 kilograms resting on a rough horizontal pavement. So there it is, the toy wagon. So a boy pushes the wagon so that it rolls along, moving at 1.2 meters per second, past a girl standing alongside the path. So this boy here pushes this wagon here with a velocity of 1.2 meters per second, and it passes this girl here. So when it passes, as it passes, the girl here, she dumps. They're talking about this girl here. She dumps a bucket. Where am I? Oh, she dumps a bucket of sand, of sea sand, onto the wagon. So as the wagon passes there, this girl here dumps a bucket inside the wagon, and when this happens, the wagon slows down and continues to move at 0.5 meters per second to the left. So let's look at the first question. It says, write down in words the principle of conservation of linear momentum. It says that the total linear momentum in an isolated system remains constant in magnitude and direction. You get your 2 marks there. So let's do the second question. So it says, using the principle above, or using the principle in question 7.1, calculate the mass of the bucket of sea sand that the girl dumps onto the wagon. So let's do it here. But first I want us to discuss what is happening here. So this wagon here was moving to the left with a velocity of 1.2 meters per second. So this girl here dumps this sea sand into the wagon troy here. So when this happens, this wagon troy slows down. Why does it slow down? Because right now it feels heavier. That is why it is slowing down, because you increased the mass. So let's do 7.2 there. Using the principle in question 7.1, calculate the mass of the bucket of sand that the girl dumps onto the wagon. So here we're going to use the principles of conservation of linear momentum. M1 V1 initial plus M2 V2 initial is equals to M1 V1 final plus M2 V2 final. So let's substitute in what we know. So okay, so initially we had a wagon of mass 6 kilograms. It was moving to the left as at 1.2 meters per second. So I am choosing to the left as positive. So plus the sea sand. We do not know the mass of the sand there, so I'm gonna say M. But we know that initially it was at rest, it was not moving, so it is 0 is equals to the wagon mass 6. They told us that it was moving to the left at 0.5 meters per second. Let me see if I can there. So after this happens, it moves to the left with 0.5 meters per second, and plus M. Since they are both moving at the same velocity, so I'm going to substitute in 0.5 here and 0.5 here. And I know that some teachers might ask you to combine these masses here, but I don't think that is necessary, because sometimes you might not know which formula to use. So just use this formula because it works all the time. This formula here works all the time. The one that you factor out the mass, and I don't think that thing there is necessary. So let's simplify here. So 6 times 1.2, 6 times 1.2, it is 7.2. Sorry, it's 7.2. 7.2. M times 0, it will give us 0. So 7.2 plus 0, it is just 0. So 6 times 0.5, it is 3 plus m into 0.5. So 7.2 minus 3, let me see, minus 3 is 4.2. 4.2 is equals to 0.5 m. So we divide both sides by 0.5, we get that m is 4.2 divided by 0.5 is 8.4. So the mass of the sea sand is 8.4 kilograms. Let's move to another question. Draw a velocity versus time sketch graph to illustrate the motion of the wagon before and after. So we want before and after. The bucket lines on it show the initial velocity and the final velocity values on the vertical axis. So to draw I told you the important things when to draw the graph. So 7.3, we will start with the line of the y-axis, and then we will do the line of the horizontal axis. So here is x and here is y. So let's label x and y. So on y, they said velocity versus time. So it's y versus x. So velocity is on the y-axis, so it's velocity. But velocity we know is measured in meters per second. And time is on the x-axis. Time we know is measured in seconds. So what is the initial velocity of the wagon? It's 1.2. They give us there, it's 1.2. And what is the final velocity? It's 0.5. So you can see that this graph here will not cross to the negative y-axis. So the graph will look like this. Let me do this here. Let me do this. Can do better. Like this here. So this is how you draw your graph, because after collision it is still moving to the left. And thank you for watching. I will see you next time.